Good morning, everyone. All right, great attendance. I love this. Let's talk a little bit about navigating the hype in AI. So I'm glad you all came today. That's what our focus is going to be, is artificial intelligence, but primarily how do we use artificial intelligence in an OT environment, in an industrial control system itself, okay? Term gets thrown around a lot these days. Let's make sure we get a good definition. So one thing that I think we all was not a surprise, right? Our company, Darktrace, that I work for, we put out a poll to over about 1,800 global leaders across a lot of different organizations, and we got back some great feedback. There's a QR code if you want to scan the report there. You can take a look at some of the other statistics. But primarily, 95% of the global leaders realize, yes, we need AI. We have to bring that into our organization. We have to leverage AI to really uplift and power our systems if we're going to defend against the threats that are coming around the corner. But one thing that was quite surprising to me, and while I'm here today speaking to you, is we asked the question, do you really understand the different types of AI that are in these platforms? And only 26% of the folks that responded said they had a good understanding of what those AI features were and how they functioned inside those platforms. So let's demystify some of the different AI terms that we use. A lot of vendors, a lot of tools are claiming that they use AI, and they are, but to what depth, to what capability do these different forms of AI have? So that's really what we're going to focus on today. What I like to start with is supervised machine learning, right? I like to focus on the attack-centric terminology for this, right? Because when we leverage supervised machine learning, we're looking for things like known attacks, attack patterns. And that makes sense, right? Primarily, a lot of the times when we hear AI and we combine that with OT security, what are we talking about? We're talking about threat detection tools. Tools that are looking for threats, detecting threats. Well, how do we do that? We do that by leveraging supervised machine learning. We're leveraging also the training data, things like static data, right? When I mean by static data or attack scenarios, attack patterns, they're CVEs, right? TTPs, right? Threat intelligence feeds, right? We're all familiar with this. Information sharing. We're sharing one threat from one organization, we're bringing it into another, we're feeding that in. We can leverage supervised machine learning to look for these threats, look for these known attack patterns, right? What does this data look like? Well, it's pre-labeled, right? It's pretty straightforward, right? A CVE is pre-labeled. We know what a CVE is. We know the exploits. We know the CVSS score information. We know the EPSS score information. So it's very easy to collect that information and pull it in. And we all get the alerts from CISA, right? We know that every single day more and more CVEs are coming out. So this is good quantifiable data that we can access, we can pull in, and we can leverage inside of a platform. And we can enhance that with supervised machine learning. What are some of the models? Well, we're going to leverage models, things like attack scenarios. So we're pre-training and we're understanding, focusing the AI to look for specific attack patterns, right? What are we seeing in that pre-labeled data that's going to identify a threat inside our environment, okay? The big use case here, like I mentioned, is known attacks, right? So the supervised machine learning is looking for things that it sees in the pre-labeled data, in that training data. So if it's not known, that's one of the main limitations, right? You cannot detect an unknown threat, okay? So if Putin's working on something new that's coming out next week, he's going to attack your facility, definitely something supervised machine learning is not going to be able to detect. All of the known attacks that are out there does a fantastic job of identifying that. Okay? But as you can imagine, as I hinted at the CISA alerts that we all get on a day-to-day basis, this is an exhaustive amount of data. There's so much threat intelligence feeds that we could access, so many CVE data information that we could feed in, right? Known attack patterns, TTPs, MITRE, a lot of good organizations that are feeding this threat intelligence information out there. It can be quite exhaustive, right? So it's a big challenge for the vendors to make sure they're pulling in quantifiable data, leveraging the right data to make sure that our supervised machine learning is doing what it's intended to do inside your environment. Okay? When we look past supervised machine learning, we start talking more about unsupervised machine learning. So we leverage up from there, what value are we really getting, right? Use cases for unsupervised machine learning are unusual behavior, right? Unknown threats, novel threats, okay? So this is what you want. If you're worried about Putin coming after your facility, right? Maybe I shouldn't say Putin too many times. Usually when I mention him on a Teams call, that's usually when my Teams disconnects or hiccups for a minute. But the lights are still on. I think we're okay today. But if we're looking for novel threats or new threats that have not been detected yet, unsupervised machine learning is going to do a great job at this, okay? Another thing that's going to help us out with is quality assurance, right? Or predictive maintenance, okay? And we do that through leveraging some of the models that I have here, right? When I talk about probabilistic modeling or relationship analysis, this does a great job of identifying different types of device characterization. When we move past supervised machine learning, something focused on pre-trained or label data does a really good job of saying, hey, I know exactly what a Schneider PLC looks like. I know exactly what a Rockwell or Allen Bradley HMI operates like. We can tag that device, we can identify the device, very straightforward information. When we start talking about a little bit different than that, nuances of these tools, right? They can be configured in different ways. We can leverage unsupervised machine learning, things like the relationship analysis, the probabilistic modeling. What is a device potentially going to do? And we leverage that to make sure that we're identifying the right type of devices inside of an environment, okay? The training data, and this is why I go back to the term business-centric, right? We mentioned the training data for supervised machine learning is truly focused on things like threat intelligence, CVEs, MITRE ATT&CK framework data, TTPs. When we talk about business-centric, we're talking about your data, right? Those tools that I mentioned in supervised machine learning, how are they detecting the threats? They're detecting it based off the information that they're being trained on, but they're detecting because they're ingesting network traffic primarily, right? Every vendor that's here today at S4 primarily puts an appliance or a span port on a switch or a tap off of one of your network components, ingests that traffic and analyzes it, looking for those known threats. Well, if we're doing the same thing with unsupervised machine learning, we're taking your business data. We're looking at all of that data that's coming into an appliance, coming into a platform, and we're not just looking to see if it's good or bad and then discarding it. You can look to see if it's good or bad, and then you can analyze that traffic, that business-centric data, to leverage for some of the things that we're talking about today. So those are what we call unlabeled data sets. Your data inside your environment primarily is unlabeled. So we're pulling that in to a platform as well, leveraging that to make sure we use these advanced models to do things like attack simulation or correlation analysis, right? So we can classify devices properly. And primarily we can look for highly anomalous activity and we can detect unknown threats quite accurately. So a good delineation between supervised machine learning and unsupervised machine learning. Primarily the supervised machine learning is focused more from an attacker standpoint, detecting those known threats. Unsupervised machine learning takes it a step past that and is primarily looking for unknown threats or leveraging your data inside your environment to bring you the most value to be able to do some of the more advanced things that I'm speaking about today. Now we get to some of the really cool stuff, okay? So we talk about open source, okay, AI. We're talking about leveraging generative AI or large language models, okay? This is very, very interesting stuff. This is a lot newer, a lot more advanced that we're seeing in the OT space. And I mentioned here some of the models that we use are language, visual content, or audio. If you all attended S4 last year, and I'm sure a lot of you did, we had a fantastic presentation from Kent Anderson. He actually wrote a book called Designing Autonomous AI. If you have not seen that presentation, I suggest you go back and watch that from the S4 YouTube channel or check out Kent's book, Designing Autonomous Systems. But he gave a great example about how they use generative AI in large language models in actually a Frito-Lay facility, I believe it was. So they deployed some microphones inside this Frito-Lay facility and detected the noise coming in as the corn came into the assembly line and was crunched and processed to produce the chips. They actually listened to the sound the corn made during that process. And the corn is stored in its silos, it's outside, a lot of temperature impacts to that product, right? It's dense, it's less dense, it has more hydration, less hydration based off of the temperature. So that changes the consistency of the corn, and as it goes through the process, would actually adjust the process depending on the density of the corn. So they're leveraged some advanced forms of AI to actually use that information that they're feeding in from the microphones and adjusted that and tuned that. Okay, and that's what I see there under the training data. We're talking about iterative prompting and training. This is a lot more advanced form of AI. We have to nudge and teach and train and adjust the AI to get the values out of what we want. But you could get tremendous results with that. So I wanted to share that with y'all. If you didn't hear that or see that last year, well, something that was very impressive, very advanced that they had done. Some more common use cases that we're using for generative AI that you may see in vendors' tools are data retrieval optimization. Okay, I'm sure we're all familiar with PLC logic and read commands, write commands, reprogram commands, but honestly, have we really dug into those and read into them? It's quite complex. It's quite time consuming to kind of understand what these devices are doing, right? We can leverage a tool like a generative AI or large language models to correlate a lot of that information and provide some fantastic context around that, okay? Or summarize the content. Hey, I saw this read and write command and then we saw a reprogram. What really happened here in the field? What did we really see? What did an operator potentially do to this device? So it provides great content summarization. Above and beyond, that's something that may be a little bit more less advanced, is if we have a handful of model alerts, a handful of breaches, a handful of potential threats that are detected in our environment. we can leverage the open source AI to actually pull some of those alerts together and say, hey, inside of an event like this, what's really happening? I see 4 or 5 different events. Let's correlate those together. Let's provide a synopsis or some sort of summary of that and provide that context to an operator or onto a dashboard instead of a few small, minute alerts that might be piecemealed here and there. We can actually pull those together, provide some great summarization of an alert, okay? And we can even use it to generate PLC code. So I mentioned Kent's example inside of the Frito-Lay facility, right? We can use what we see happening inside those devices to maybe generate the PLC code to adjust and tune and make sure that we're doing the right operations inside our environment, okay? One thing I mentioned ago a second in the unsupervised machine learning is looking for preventative maintenance, okay? If we get good feedback and we're leveraging unsupervised machine learning for preventative maintenance, we can take what we learn about some of those devices, we can generate PLC code as well to maybe fine tune a device to operate within a more strict parameters to ensure that the device lasts longer, right? Or we're not gonna have any failures or any operational downtime from some of our devices. So all great examples of leveraging open source AI, okay? What are some of the main limitations, right? Accuracy is a big one for sure, right? We talk about that. The semantic analysis as well. What do I mean by semantic analysis? We can leverage generative AI to do things like look and see the word apple. Well, we know when we see the word apple, the semantic analysis can make sure that we're referring to a fruit or referring to maybe a MacBook, for example, right? So we're leveraging the tool to do lots of analysis, pull that context in to the platform. But there can be limitations with this as well, okay? And the text-based LLMs is another big advantage, another model that we'll leverage inside of generative AI. Maybe you have within your organization, it's a global organization, okay? We can leverage open source AI to maybe pull alerts together and provide them in different languages, different contexts for different teams, right? If we're ingesting traffic into an appliance, ingesting traffic into a platform, and we're doing that across a global operation, right? So we can have alerts in English in one day, right? When we have a change of the sun, maybe the SOC team adjusts into the Middle East or into the Asia Pacific area. We can take those same alerts, we can provide context, generative AI around those, provide those in a different language and provide that support or those notifications to those teams to be one step ahead to start looking in and adjusting some of those alert information and then be able to respond to the team that comes back first thing in the morning. So there's a lot of different advantages that we can leverage between supervised, unsupervised, and then some generative AI or large language models. However, a lot of vendors are throwing these terms around and they're quite broad when they say AI. So I wanted to spend some time today to maybe highlight some of these terms with you. Focused on supervised machine learning, what are the real key components of that? What are some potential limitations? Also, when it comes to unsupervised machine learning, what are the real advantages there? And what do you really have to have in place to make sure that you're actually generating some of the quantifiable benefits that you claim that the product can do? And then when it comes to generative AI, some of the claims that we're starting to see a lot more from the OT vendors themselves, the industrial vendors, the Siemens, the Rockwells, the Schneiders, the Schweitzers out there, right? They're providing a lot of this new advanced capabilities, or they're claiming and roadmapping a lot of these new features and capabilities into their tool. I wouldn't be doing my job if I didn't leave you with a little bit of ammunition as well to go back and ask questions to these vendors, okay? And I'm gonna highlight just a few here on 4 different categories, and I wanted to make sure I plant a seed with everybody to make sure they're asking these questions of vendors and you're more knowledgeable and more aware of some claims that are made. Now we'll just do a light dive on this. I do highly recommend everybody, a colleague of mine, Clinton Bodigan, will be speaking at 11 o'clock on stage 2. I highly recommend you go check his presentation out. He's gonna focus truly on evaluating vendor claims, and he's gonna go really deep into that section. So if this kind of gets you excited, I definitely recommend you go see him on stage 2 at 11 o'clock. But when we ask questions like, what are the strengths of this AI, right, of this specific approach? What are some of the limitations? I think we talked about that a little bit today, right, to remind everybody. Supervised machine learning is primarily focused on known threats, okay? We have to feed a lot of data into the platform to get that. What's a limitation of supervised machine learning? Well, if we're feeding lots of data into our platform, that means we need to be open to the internet potentially. We have to receive that threat intelligence, okay? I know a lot of organizations are potentially okay with that, maybe begrudgingly. Over the years, they've become okay with that, feeding data in from outside connectivity. But if your organization does not want to go down that route, that's something that you need to be aware of. You need to be asking these vendors these type of questions. What are potential limitations? What are strengths of some of these different AI models, okay? Does it provide accurate results for my specific use case, okay? I think from a straightforward perspective, yes, if you're looking for attacks, that would be definitely something that, that definitely provides inside your use case. But when we talk about device characterization or preventative maintenance or quality assurance, these are things that you really need to weed out and make sure you have conversations with vendors about some of their claims, okay? Things like training data. Where's the data trained from? Again, when we talk about things like known attack patterns, threat data, of course the data is trained on reliable information, right? Trustworthy information from CISA and NIST and some of these organizations like MITRE. However, when we're talking about unsupervised machine learning or device characterization, where is the devices trained from? Where's the models trained from, right? If it's trained from other cloud instances or deployments that cover a vast quantity of deployments across a handful of sites, a handful of customers, there could be a lot of bias in there or a lot of misconception with what is truly identified, right? We all know what a camera looks like, and we all know what a security card reader looks like, or a PLC or an HMI, but there's a lot of devices that are multi-function devices, right? I'm sure we're all familiar with maybe Red Lion control systems. You can create and adjust and create a lot of different variation of devices, all with a few simple circuit boards. So what one client considers potentially a badge reader or a security device, another client could be using the similar device and similar logic and code for doing something like an HMI or some other sort of process automation inside their facility. So we want to know how these devices are trained or how these models are trained to identify devices and categorize devices. It's definitely a valuable process there, right? And what measures have been used to prevent bias or any data poisoning? This is a great question to ask as well, especially when we get into some of the generative AI or some of the large language models, okay? And are they testing and evaluating this, right? What is the test case for this? What type of lab environment do they have? Are they running this through their own process? Or is the test and evaluation, we deploy it at a customer site, we tweak it and adjust it, and we take that to another customer site? You want to make sure you validate these questions before these technologies are employed inside your environments, okay? Are they pre-trained or are they continuously learning? This is a great example of the difference between the supervised machine learning and the unsupervised machine learning. I mentioned the supervised machine learning is primarily pulling in all of the data, the threat intelligence, right? The known attack patterns that are out there. And then the unsupervised machine learning is leveraging your business-centric data, okay? So if we're talking about how are they trained, are they continuously learning, right? Business-centric is continuously learning. It's always looking in your data. We want to make sure that that's adjusted and tuned properly inside your environment. And also, yes, the threat intelligence feeds or the known attack patterns are being pulled into the platform as well. So you're continuously training, continuously updating those labeled data sets to be able to detect those known threats that are out there, okay? How does the AI deal with environmental changes? Another great example. In our business, right, a lot of large industrial organizations tend to focus maybe sometimes less on the industrial operations and more on the mergers and acquisitions, right? I work with lots of different oil and gas clients. I think they're in the more in the mergers and acquisitions business than they might be in the oil and gas business, right? So if you're having one site that's typically Rockwell, right, PLCs and equipment, and they're leveraging the SIP protocol, and then you acquire another site that might be all Siemens, and it's using the S7 protocol, how are we making sure that we understand that? And we're making sure that, right, environmental changes, the models are identifying things properly, the AI is not adjusting or tweaking improperly, right? Depending on what type of systems we have, what devices that they are, what protocols that they're using, that we're ready for those environmental changes potentially in those environments, right? Something I think we definitely see from time to time, especially with migrations, new sites being added, a lot of obsolescent equipment is coming out. We're getting a lot of new devices coming in, something we definitely need to be prepared for, okay? How are false positives and negatives handled as well, okay? Are we teaching or training, or do we have to teach or train the AI itself to weed out false positives, right? This is a big value question to add, right? If we're deploying a solution, we want to make sure it does what it says that we do. We don't sign ourselves up for being obligated to train or teach the AI, right? If our intention is to deploy a solution and have it detect threats and be aware of what's going on, we don't want to make sure we're the ones detecting, hey, this is a false positive, you can mute that out, you don't need to tell me about that anymore. We want to make sure we have empowered the AI to do those things for us, right? Whether it be the supervised or the unsupervised machine learning. And most importantly, and I emphasize this a lot, right? Does the vendor explain the different machine learning techniques used, or do they just say AI, right? I'm a big fan of OT. I spent my whole career working in OT space. Yes, I admit I'm a nerd. I like to go on YouTube and I watch all the different vendors' videos. I love to see all the different platforms from everybody that's out there. But so many times I go to YouTube, I see a new thing in my feed and it says, using AI to do this, using AI to do that, and I get suckered in and I watch that 50-minute demo video, and not one time in the 50 minutes is the term AI even used, right? So a lot of keywords, a lot of focus points are based around AI, But when you get into the meat and the potatoes, sometimes they're not actually using AI, or they're not really getting in the details of the machine learning and how they're leveraging that. So I definitely emphasize, does the vendor explain the different type of machine learning that they're using, right? We just don't want to use the term AI. We want to hear things like, we're using supervised machine learning to do X or to do Y, or we're leveraging unsupervised machine learning for Z, right? We want to make sure that we're understanding this and the vendor is claiming one thing and actually backing that up with other information as well, okay? And then how is the data stored, most importantly and lastly, right? I talked about the supervised machine learning. It requires internet connectivity, requires those feeds. Are they leveraging a cloud platform? Is data or knowledge or anything gleaned about your environment fed up into the cloud and stored into the cloud? I mentioned on unsupervised machine learning, we're focused more on your business-centric data. So I think you're going to see a lot bigger shift or a lot more focus on maybe having on-prem solutions. So these are questions that you need to ask. Where is my data analyzed? What models are using? And most importantly, where is the data stored? Where are the models adjusted? Where do I have access to that data? Is it up in the cloud where others can potentially access that? Or is it locally on-prem with my devices? Okay? Thank you very much for your time today. We'll definitely leave a few minutes for questions. Thank you. There's a microphone in the center of the room. I direct anybody over there for questions. Thank you so much, sir. Go for it.
Great presentation. Being on the security side, I'm more concerned about how AI can be used to create disruptions. So for example, it's very focused on fine-tuning, finding out what's normal, normalizing it, making sure that it's working perfectly. But what if an attacker decided to create disruptions by either introducing extraneous noise that created enough noise to cause the tuning to go out of sync, and or to shut down the systems altogether, thus having a denial of service? Is there anything built into the model that will account for that, catalog it, and then cause something other than a shutdown in the processes in order to prevent disruption?
Yeah. So one of the benefits of leveraging this advanced AI as well, I mean, when we have such a good understanding of what's happening in your environment, and we can leverage AI models to really understand and ingest your business-centric traffic, one huge advantage is potentially talking about the response components. How do we respond to attacks as well? So when you talk about a more advanced attack, leveraging AI, maybe poisoning of data, large-scale attacks to bring down a site, I would hence to focus on leveraging AI for a response mechanism. If we understand truly what's happening in the environment and we're leveraging the AI to do that thing, right, and really learning what's in there, we can feel confident about responding to an attack and actually stopping a threat a lot more quicker, a lot more advantageous than we would from maybe like an incident response case or things like that where we're taking our time to do an investigation. If we clearly see something that's highly anomalous and highly out of context, then recommending a more offensive response to that is something that definitely should be considered and would be a great offensive game plan to maybe stop a more advanced attack like that. Cool. Great question, sir. All right. Thank you so much.